Okay, the graph of f at x is shown. On each of the following diagrams, draw the required graph. So this is where we're going to multiply points by 2, the y coordinates by 2, because it's outside the function. So 0, 0 stays. 1 is the x, so that stays, but the y coordinate 1 multiplies by 2 to up there. 2, 0, the 2 stays, but the 0 gets multiplied by 2, it's 0. 3, negative 1, the 3 stays, but the negative 1 gets multiplied by 2, so down here. And same with 4. And then we would connect that with a straight edge, hopefully. Now, f at x minus 3, that's inside the brackets, horizontal, so everything moves to the right 3 units. So 0, 0 moves here. 1, 1, moves here. 2, 0 moves to 5, 0. 3, 1 moves to here. And 4, negative 1 moves to 7. Everything right 3. Okay. The point 3, negative 1's on the graph of f. The point A prime is the corresponding point on the graph of y equals negative f at x plus 1. Find the coordinates. So for this one, if we start with 3, negative 1, okay, we are going to have that, first of all, it gets flipped over the y-axis. So it's going to become 3, positive 1. And then we add 1 to the y-coordinate, so it's going to be at 3, 2. All right, number 6, we've got f at x here. Consider the five graphs in the diagrams. What diagram is the graph of f at x plus 2? So that's everything to the left 2. So it's going to be the graph of D. Negative f at x, that's flipping over the x-axis. So we are going to have C for that one. And negative f at negative x is flipping over the y-axis. So this is A. Write down an expression for the 2 remaining graphs. So B is going to be f at x, and we're going up 2 units. Everything moves up 2. And this one is going to be f at x, and we're moving to the right 2 units. All right, we've got f at x from 0 to 4. Write down the values of f at 1 is 1. Right there. F at 3 is 1/2. On the diagrams below, draw the graphs of 3 negative f at negative x. Okay, so if we flip everything over the y-axis, okay, this stays. Then this, all these are flipping. 2, 1 goes to negative 2, 1, and 4, 0 goes to negative 4, 0. All right, so I'm not going to connect those because now I'm going to multiply everything by 3. So the y coordinates by 3. All of this moves up here, and that stays there. So my final graph is looking like that. Okay. Now, if we have f at 2x, that's just one where we divide the x's by 0. So the 0, 1 stays. 1, 1 becomes 1/2 1. 2, 1 becomes 1, 1. And 4, 0 becomes 2, 0. Everything is divided by 2. Okay, so now we want the domain and range. So the domain of this one's going to be negative 4 to 0. And the range of that one is 0 to 3. Those are the y's you use. And then domain here is 0 to 2, and 0 to 1 is the range. So then we've got this f at x. Okay, so we're going to flip everything over the y-axis, it's negative x's. So negative 2, 2 flips to 2, 2. And negative 1, 2 flips to 1, 2. 0, 3 stays there, or sorry, 0, 2, sorry. 1, 1 flips to negative 1, 1. 2, 0 flips to negative 2, 0. 3, 2 flips to negative 3, 2. And we've got 4, 4 flips to negative 4, 4. Okay. And then g at x is this point 3, 2 on the graph of f is transferred to the point of P on the graph of G. Okay, so that's F, 3, 2. It shows it there. All right, so this is moving right 1, so that's going to be 4, 2. And then we do 1/2 the y's. So it should be this as your final point. All right, on the same grid, sketch the graph. So everything's flipping over here. So 2, 1 flips to negative 2, 1. 3, 3 flips to negative 3, 3. And 4, 1 to negative 4, 1. So like this. The following 4 diagrams show images of f under different transformations. Complete the table. Okay, so this is our original f function up there. And we want a horizontal stretch with scale factor 1.5. So it's getting wider, so that's clearly C. Just in the function, it would be 2/3 x. Okay, because we would be dividing by 2/3, which is the same thing as multiplying by 3/2. All right, maps f at x to f at x plus 1. So everything's moving up, so we need 4, 2. Oh yeah, it's D. Okay, give a full geometric description of the transformation in A. So it's not changing, there's no scale or anything, but it is moving. Like I'm looking at this point, the peak. So we've got this point is moving to here. So we're moving left 6. So left 6 and down 2. So it would be f at x plus 6 minus 2. All right, so for 10, we've got this cubic, the max point at A and the min point at 3, negative 9. Okay, so we need to go to the graphing calculator. Okay, so if we want to find the maximum, we need to go to the menu, analyze graph, maximum. And then it says lower bound, so we need anywhere on the left side of the maximum, which is right there. So anywhere over here, okay? I just click there. Upper bound, anywhere on the right side of the maximum. That point that you're looking for needs to show up, okay? So that's the max. So we're going to have negative 1, 1.67. All right, write down the coordinates of the image of B after a reflection in the y-axis. So that's where your x's become negative. So that's going to be the point negative 3, negative 9. The image of B after a translation by minus 2 units in the x direction. So that's going to be at 1, negative 9. And then 5 units in the positive y. So that's going to be 6, negative 9. Ooh, sorry, no, it's not. In the y direction, that's 1. And then y moves up 5 units, so that's going to be at negative 4. The image of B after reflection, the x-axis. So that's going to be 3, positive 9. It flips over the x-axis to be a positive y, followed by a horizontal stretch with scale factor 1/2. So this is going to be 3/2, 9. Okay, so 11, the graph of a function f is shown there. On the same diagram, sketch the graph of negative f at x. So that's where everything flips over the x-axis. So negative 1, 4 flips up here. Negative 1, negative 4. Then we are going to have 1, 0 stays there. 3, 0 stays there. And let's get some. It's like 0, negative 1.5, so up here, and 4, negative 1.5, so here. So we have, and then this flips there. So that's how that looks. Let g of x equals f at x plus 3. If we want g at 3, negative 3, gosh, that's f at negative 3 plus 3, which is f at 0. So f at 0 is this one, negative 3 over 2. And describe fully the transformation that maps the graph of f to the graph of g. Graph of f to the graph of g. So it's just a translation, a shift to the left 3. Okay, so write down in the table the domain and range of the following function. Okay, so if you're just flipping over the x-axis, the domain doesn't change. So that's still going to be negative 1 to 4. But the range will change. So you can see that it's going to be from negative 1/2 to positive 4. And if we go over f at x plus 3, the range is not changing because the y's have not been affected, but the domain, everything shifts to the left 3. So this is going to be negative 4 and 1. So we would subtract 3 from each of those. Okay, so we have this f at x, its max and min are given. On the same diagram, draw that. Okay, so we're moving right 1, up 1.5. Okay, so we've got right 1, up 1.5. So there. Okay, I'm just picking points. So right 1, up 1.5 there. So right 1, up 1.5. So about there is that first point. All right, this one goes right. Oh no, I'm not doing it right. Okay, we need to go right because it's like a different scale. So right 1, up 1.5 here. This goes right 1, up 1.5 here. This one goes right 1, up 1.5 here. This one goes right 1, up 1.5 here. This one goes right 1, up 1.5, and that one goes right 1, up 1.5 here. So like this. Something like that. All right, B, right, what are the coordinates of the min and max point? So it goes right, so 0, 0 goes right 1, up 1.5. And 1, 1.5 goes right 1, up 1.5 to 2. All right, 13, a sketch shows which passes through the points that. Second function is defined by that. Calculate g at 0. So if we have 0 is originally at 2 for the f function, and then we've got, this is going right 1, and then multiplied by 2 on the y's. So g at 2, it was at 2, 1. So it goes right 1 to 3 and multiply by 2 on the y's. And g at 3 is 5. So right 1, multiply by 2 on the y's. On the same axis, sketch the graph of the function gx. Okay, so 0, 2 becomes 1, 4. A was negative 1, 3, so we're moving right 1 to 0, 6. And then negative 3-ish, okay, it's not perfect, but negative 3, 0 is going to be at negative 2, multiplied by 2 is 0. So here, so we're going to go up like this and down. Here we are at 1, 4. That's B. And then we've got 3, 2 here. But we missed the point C, which is 1, 0. So that's going to be right 1 and then multiply by 2 on the y. So 2, 0 here. Okay, so it should come down like this and then up. And then 3, 5 move to 4, 10. So we just kind of keep going up there. And that should be it. All right, we've got this linear equation. So we've got start at the y-intercept 1. And then we need to go up 2 over 1. That's not up 2. Up 2 over 1. And then up 2 over 1. So that's good for 0 to 2. And then let G be that. And now we need to draw the graph of G. Okay, so these points need to go left 3. 1, 2, 3, and down 2. 1, 2. So left 1, 2, 3, down 1, 2, and left. Okay, so I can just go up 2 over 1. And we went from -3 to -1. So that's that. That's G. Write down the range for each function. Whoops. So we've got that this is obviously, oh no, not obviously. So 1 to 5 for the, I'm doing this because I keep wanting to. And then -3 to 1 goes from -1 included to 3. This is interval notation. All right, 15. The diagrams show how the graph of x squared is transformed to f of x in 3 steps. So, in the table below, give the equation of the curve for each diagram. Okay, so this is going to be y equals, we've moved it all to the right one, so that's going to be x minus 1 squared. Okay, so this one in double I, it is done. It's got a stretch on it by 4 because it was at 1 and then it gets multiplied by, the y's get multiplied by 4 to get up here. And still it's moved right 1. So now we've got like this and then it's moved up 3. Write down the coordinates of the vertex at each step. So, okay, 1, 0. Still is 1, 0 for a double I, and then it becomes 1, 3. All right, we've got f at x and g at x. The graph of g can be obtained from the graph of f using 2 transformations. Give a full geometric description of the 2 transformations. So for A, we're moving right 1 and vertical stretch scale factor 2. All right, so for B, the graph of G is translated by the vector 3, -2. So 3 units in the x, -2 in the y to give H. The point -1, 1 on the graph of F is translated to the point P on H. Find the coordinates of B. Okay, so first of all, -1, 1 was on F. Then it goes to G. So first of all, we move right 1. So that's going to be at 0, 1. Then we multiply the y's by 2. So that's 0, 2. And then we have that it's shifted 3 units in the right, so to the right. So that's going to be 3. And then 2 units down in the y, so that's going to be 0. So that's the final point. All right, 17, the graph is translated 1 unit right, 2 units down. G is the image of F after this translation. Write down the coordinates. Okay, so the coordinates of F are just 0, 0. If we wrote it like this, that's the coordinates. So G is going to be 1 unit to the right, which is going to be 1, and 2 units down, so -2. And we want to express g at x like that. So it's going to be 3x minus 1 squared minus 2. The graph of h is the reflection of the graph of g in the x-axis. Write down the coordinates. So this is just flipping over the x-axis. So it's going to make the y's the opposite sign. So 1, 2.